Hello students, myself is Parminder Singh from Prab Kripa classes. Our today's topic is calculating volume of cones, formulas and methods. After going through this course, the students will understand the meaning of cone. They will also understand what is the difference between right circular cone and oblique cone. They will know what is meant by height and slant height of a right circular cone. The students will also understand what is the formula to calculate the slant height of a right circular cone. They will also understand the relationship between radius, height and slant height of a right circular cone. They will also understand how the formula, how the volume of the cone is calculated. That is, they will understand the formula to calculate the volume of a cone. Now we will understand what is the meaning of cone. A cone is a three-dimensional geometric shape. It is made up of a flat base which is usually in the shape of a circle. The shape of the cone gets narrower smoothly from the circular base to a pointed top. You can see that the shape of the cone is slowly getting narrower and it is forming a pointed top. The shape of the cone looks like an ice cream cone as well as like a traffic cone, which you might have seen at the traffic signals, which are for the purpose of controlling the traffic. Now there are two common types of cones in mathematics. First is right circular cone and the second is oblique cone. Now we will discuss each of these cones in some detail. First is right circular cone. Right cone is a cone in which the base is circular and the apex, that is the pointy part, is directly above the center of the base. You can see here that this pointy part is directly above the center of the base. The axis of the right cone, which is a straight line and passing through the apex and the center of the base, is perpendicular to the base. It means that this line, which is attaching the base, center of the base with the pointy part, is having 90-degree angle at the base. Now the second cone which we will discuss is oblique cone. This cone is the cone in which this pointy part is not directly above the center of the base. You can see here that if we assume that this is the center of the base, then this pointy part is not directly above. If we raise the directly above the center of this base, this will come here, but its pointy part is here. So this, if we join this part with this, it will not be in forming a 90-degree angle. So instead the axis is slanted in relation to the base. So the shape of oblique cone is not perfectly straight or symmetrical, and this cone looks like a slanted cone or a tilted cone. Now the radius of the base is denoted by the letter R. The slant height of the right circular cone is the distance from the apex to any point on the perimeter of the base. Perimeter means the boundary line of the base. It means that if we measure the distance from the apex, that is the pointy part, to any part on the perimeter of the base, it will be the slant height, which will be denoted by L. The height of the right circular cone is the distance from this apex to the center of the base. You can see here that from here to here, this is the height and is denoted by the letter H. Now we will again discuss slant height. In a right circular cone, the height H, radius R and the slant height L are related by the Pythagorean theorem, which states that L square is equal to R square plus H square. This relationship can be used to calculate any of the three values if the other two are known. It means that suppose we have been given in any mathematical question the value of R and the value of L, then we can calculate the value of H. How we can calculate? From this formula we can calculate H square is equal to L square minus R square, because from here R square will go to this side and it will become minus. If suppose if we have been given the value of H as well as L, that is the height and slant height in any question, then we can calculate the value of R. How we can calculate? R square is equal to L square minus H square, that is radius square is equal to slant height square minus height square. So you can see that height H, slant height L and radius R related to each other, and the formula is this one. Next, you will also observe that we have already uploaded many courses such as tips for crafting engaging speeches, good communication skills, how to manage stress in our life, job application format, unlocking the power of mental wellness, mastering Huron's formula, most common mistakes in English grammar, 13 useful resume writing tips, what must be in your CV, resume, biodata, present tense, past tense, future tense, and many courses on cyber security. You can also look out for the same. Now the topic before us is volume of a right circular cone. We have already learnt what is the meaning of right circular cone. Now we will do an experiment to find out the volume of a right circular cone. For that purpose, we make a hollow cylinder as well as a hollow cone which have the same height. You can see here that this cylinder and this cone have the same height, and the base radius of both, that is the cylinder as well as the cone, is the same. You can see here that this is the radius of cylinder and this is the radius of the base of the cone, which are same. So we will try to find out the volume of a right circular cone. Now you can see that first of all we will fill this cone with sand fully up to the brim, and we will then empty it into the cylinder. When we empty this cone into the cylinder which is full of sand, we will find that this cylinder is only filled only partially. Then we again do the same thing. We again fill the cone with the sand up to the brim and then again empty it out in the cylinder. We again find that the cylinder is not fully filled. Then for the third time again we repeat, we fill the cone with the sand and empty it into the cylinder. But here we will see that this cylinder is now totally filled. That is, when we do this process for 3 times, that is, we put the sand which is filled in the cone, we do this process 3 times, the cylinder will be fully filled. So what we have seen, we can safely come to the conclusion that when the cone and the cylinder have the same height and have the same base radius, then the 3 times the volume of the cone makes up the volume of the cylinder. In other words, we can say that volume of the cone is 1/3 the volume of the cylinder. So volume of the cone is 1/3 pi r square h, where r is the base radius and h is the height of the cone. Now the question before us is, the height and the slant height of a cone are 21 centimeter and 28 centimeter respectively. We have been asked to find out the volume of the cone. Now this is the cone before us. And what has been given to us? Height. This is the height, and height is 21 centimeter. And the another item which has been given is slant height. This is the slant height, this one. Slant height is represented by word L, letter L. This is 28 centimeter. Now we are to find the volume of the cone. By applying the Pythagorean theorem, we understand that there is a relationship between slant height, height and radius, and the formula for the same is L square is equal to R square plus H square, where L represents the slant height, R stands for radius, and H stands for height. So here we can find out the third item, that is, we have been given here slant height and height. So we can find out the value of R. R square is equal to L square minus H square. We will fill in the values. It comes L square is, L is 28 square minus height 21 square. In other words, we can say that R is equal to under root 28 square minus 21 square. Now what will it come out? 28 into 28. Seven eight four minus it is 441. 784 minus 441, 343. We will do, this is R, which can also be written as 7 into 7 into 7. Now these two become 7 under root 7. So this is the value of radius which has been come out. This is centimeter. Now we have to find out the volume of the cone. Volume of cone is equal to 1/3 pi r square h. 1/3 pi means 22/7. What is the value of r? 7 under root 7, 7 under root 7 into height. Height its value is 21. 1/3, 22/7 into this 7 and this 7, and when this under root 7 and under root 7, one under root will go out. So here we will solve 7, 7, 3, 7. So what is balance? 22 into 7 into 7 into 7. 7 into 7 into 7. 3 times 7 we have written as it comes 343 multiplied by 22. 343. Seven, 5, 4, 6. So volume of the cone is 7, 5, 4, 6 cubic centimeter. This is the answer. Now the question before us is, Monica has a piece of canvas whose total area is 551 square meter. She uses it to have a conical tent made with a base radius of 7 meter. Assuming that all the stitching margins and wastage incurred while cutting amounts to approximately 1 square meter, find the volume of the tent that can be made with it. Suppose this is the piece of canvas which is available. And its total area is 551 square meter. And Monica uses it to make a conical tent. This is the conical tent. Base radius of the tent is 7 meter. This is the radius and this is equal to 7 meter. So when we are using a piece of canvas for making the conical tent, some of the canvas will be wasted towards stitching or wastage of the canvas. So here the wastage or the stitching margins have been given as 1 square meter. So we can say that the curved surface area of the tent. So we write here area of canvas has been given as 551 square meter. So wastage of canvas towards stitching and cutting is equal to 1 square meter. It means that this is the total area of the canvas and this is the wastage towards cutting and stitching. That is the curved surface. Actually, the canvas who will be covering the tent will be, so the area of canvas used for tent is 551 minus 1, 550 square meter. It means that when we fold a canvas to do stitching, some of the canvas goes inside and the outer area of the canvas which is appears to us is the curved surface area of the tent. That is, whatever goes inside the tent towards stitching is not visible to us. So the curved surface area of the tent is 550 square meter. This is the canvas which was available for making the tent. So now what is the formula of curved surface area? Curved surface area is equal to pi r L. It is 550. Now what is the value of pi? It is 22/7. What is the value of r? R is 7 into L is equal to 550. 7 cut Simon, 22 L is equal to 550. What is the value of slant height? It comes as 25. L is equal, value of slant height is 25 meter. So now we have before us value of R as well as value of L. We know that there is a relationship between slant height, radius and height, and that is shown by the formula L square is equal to R square plus H square. Now we can find out the value of height, that is this one, this area. We can find out the value of this one, height. H square is equal to L square minus R square. Then what is the value of H? It becomes L square minus R square. We will fill in the relevant values. Value of L is 25. What is the value of R? It is 7. So we have find out the value of height. It is 24 meter. Now we have before us the value of radius, value of slant height, and the value of height. Now what is the formula for finding out the volume of tent? Volume of a conical tent is equal to 1/3 pi r square h. 1/3 r square. What is the value of r? It is 7. 7 into 7. What is the value of h? It is 24. 7 cut 7. 8. What we have? 7 into 8. We will multiply. It is 1232 cubic meter. So we will now wrap up this question. We have find out the answer. We will again explain what has happened. That a cloth of that a canvas has been given to us, and we have to use that canvas for making a conical tent. And while making the conical tent, you understand that some of the canvas is lost towards cutting and wastage, and the cutting or wastage has been also given to us. When we reduce the cutting from the total area, we find out the actual canvas which has been used for making the tent, this curved surface area, because the tent does not have the base, because we have not to spread the canvas on the base of the tent. We have to use the canvas only for making the curved surface area of the conical tent. That is the outer portion we have to cover. So when we reduce this wastage from the total canvas which is available to us, we come to know the actual canvas which has been used for making the tent. This is 550 meter. From that we calculate, we know that the curved surface area is pi rl. From that we can calculate the value of slant height, and we also know that there is a relationship between slant height, height and radius. From that we can calculate the value of height, and we know that the volume of a conical tent is 1 over 3 pi r square h, and when we have the value of h, we can fill the value of h and arrive at the answer. Now the question before us is, find the volume of a right circular cone with radius 6 centimeter and height 7 centimeter. We have been asked to assume pi is equal to 22 over 7. So this is the cone which we have. This has radius is equal to 6 centimeter, and this is the height. This height is 7 centimeter. This is radius, this is height, which touches center of the base with the pointed part. We have to find the volume. So here we have been given radius as 6 centimeter. We have been given height as 7 centimeter, and we have to calculate volume of right circular cone. And what is the formula for calculating the volume of the cone? It is 1 over 3 pi r square h. We fill in the relevant values. What is the value of pi? It has been given as 22 over 7. What is the value of r? It is 6 square. Then what is the value of h? Height is 7. 7 divided by 7, 6 is divided by 3. So what is left is 22 into 12. Two 264 cubic centimeter. This is the volume of the right circular cone. This is the answer. Now we are to find the volume of right circular cone with radius 3.5 centimeter and height 12 centimeter. We have been given to assume pi is equal to 22 over 7. So here it is the cone. Here this is the radius. This is the height. This radius is 3.5 centimeter, and this is the height. This is 12 centimeter. We are to find the volume. So radius is equal to 3.5 centimeter. Height is 12 centimeter. What is the volume of cone? It is 1 over 3 pi r square h. We will fill in the relevant values. What is the value of pi? It is given in the question, 22 over 7. What is the value of r? It is 3.5 into 3.5. What is the value of h? It is 12. We will solve it. 1 over 3 into 22 over 7, 35 over 10, 35 over 10 into 12. We will cut it. 7, 2, 7, 2. This will cut here. This will again cut. This 7 will cut this. This 3 will cut this. So now what we have? This item 22 and this item 7. 22 into 7. So what is? The answer before us is 154 cubic centimeter. This is the answer before us. Now the question before us is, find the capacity in liters of a conical vessel with radius 7 centimeter and slant height 25 centimeter. So this is the conical vessel. This is the radius. This is the height and this is the slant height. Slant height is this one, which is slanted. It is 25. Radius is this one. This is 7 centimeter. Height is this one, which is not known to us. So we will write here radius is equal to r is equal to 7 centimeter. Slant height L is equal to 25 centimeter. Height is not known to us. What is the value of capacity in liters of the conical vessel? It means that we have to find out the volume of the conical vessel. What is the capacity in liters is equal to volume of conical vessel. What is the volume of the conical vessel? It is equal to 1 over 3 pi r square h. So we will have to first find out the value of h so that we can arrive at the volume of the conical vessel. We know that the L square, that as per the Pythagorean theorem, slant height, height and radius are related with each other. So the formula is L square is equal to r square plus h square. So h square is equal to L square minus r square. H is equal to L square minus r square. This is under root. We will fill out the relevant values. What is the value of L? It is 25. What is the value of r? It is 7. 6 to 5, 49. It will come as 576. Then answer is here. Value of height is 24 meter. So we will put in here the values. 1 over 3, 1 over 3. What is the value of pi? It is 22 over 7. What is the value of r? It is 7. What is the value of height? It is 24, which we have calculated. 7 divided by 7. What we have before us is 22 into 7 into 8, 56. We will do. So we come here 1, 2, 3, 2 cubic centimeter. Now we have to find the capacity in liters. What we have find out it here is cubic centimeter. We know that 1000 cubic centimeter is equal to 1 liter, and 1 cubic centimeter is equal to 1 over 1000 liters. So here we will divide this value of cubic centimeter by 1000 and the answer will be 1.23.2 liters. This is the capacity of the conical vessel in liters, 1.232 liters. So now the question before us is find the capacity in liters of a conical vessel with height 12 centimeter and slant height 13 centimeter. This is the conical vessel. This is the radius, this is the height, this is slant height. From here to here, this is slant height and it is 13 centimeter. What other we have? This is the height from here to here. This is the height and this is 12 centimeter. We have not been given radius. This is the radius. So what we have is height is equal to 12 centimeter. Slant height L is equal to 13 centimeter. Radius is not known to us. Now what is the capacity of the conical vessel in liters? Capacity of conical vessel is equal to volume of conical vessel. What is the formula for volume of conical vessel? It is 1 over 3 pi r square h. So here we will have to find out the value of r. We know that there is a relationship between height, slant height and radius. So as per the Pythagorean theorem, the relationship is shown by L square is equal to R square plus H square. So R square is equal to L square minus H square. R is equal to under root L square minus H square. We will fill in the relevant values. L 13. What is the value of H? It is 12. 13 square means 169. 12 square means 144. After doing reduce after 169 minus 144, it will come as 25. Under root 25 means r is equal to 5 centimeter. Radius, this is the radius. So here we will put in the value of r and other items. It is pi, r is 5, h height 12. So here this is the capacity of the conical vessel or volume in cubic centimeter. Now what is the question? We have to find the capacity in liters. We know that we know that 1000 cubic centimeter is equal to 1 liter, or we can say that 1 cubic centimeter is equal to 1 over 1000 liter. So here 1 over 1000, it will come as 11 divided by 35 liters. This is the answer. This is the capacity of the conical vessel in liters. Now the question before us is, the height of a cone is 15 centimeter. If its volume is 1570 cubic centimeter, find the radius of its base. The value of pi has been given as 3.14. So this is the cone. This is the radius and this is the height. Height has been given as 15 centimeter. The value of radius is not known or have to be calculated. So height h is equal to 15 centimeter. Radius is equal to r centimeter. So what is the volume of the cone? Volume of cone is equal to 1570 cubic centimeter. Now what is the formula for calculation of volume of the cone? It is 1 over 3 pi r square h is equal to 1570. We will fill in the relevant values. The value of pi has been given as 3.14. What is the value of r? It is not given. What is the value of h? It is 15. Is this. We will cut. So 3.14 into 5. So this is r square is equal to 100. R is 10 centimeter. This is what we will have to calculate. Radius is equal to 10 centimeters. Now the question before us is, a conical pit of a top diameter 3.5 meter is 12 meter deep. What is the capacity in kiloliters? This is the cone. This is the radius. This is the height. What we have been given is diameter is 3.5. It means that from here to here it is 3.5. It is diameter. It has been given that it is deep 12 meter. Deep means height of the cone. This is 12 meter. So here diameter is equal to 3.5 meter. We know that radius is half of diameter. Diameter over 2. So what is the value of diameter? 3.5 divided by 2. It is 1.75 meter. This is the value of radius. Now what is it? It has been written as that conical pit is 12 meter deep. Deep means height. Height h is equal to 12 meter. So we have to find the capacity of conical pit is equal to volume of conical pit. So what is the formula for volume of conical pit? It is 1 over 3 pi r square h. We will fill the relevant values. What is the value of pi? It has been given as 22 over 7. What is the value of r? It is 1.75. What is the value of h? It is 12. We will solve it. 1 over 3, 22 over 7, 175 over 100, 175 over 100 into 12. We will divide it both the sides by 25. 7 will be cut, 7, 4 will be cut here, 3 will be cut here. So what is the balance with us? This will be cut. What is the balance? 77 over 2, 38.5 cubic meter. So now what we have to find is that the capacity has to be found in kiloliters. We have the answer as 38.5 cubic meter. We know that 1 cubic meter is equal to 1000 liter, or we can say that 1 cubic meter is equal to 1 kiloliter. So 38.5 cubic meter is equal to 38.5 kiloliters. So the answer is capacity is equal to 38.5 kiloliters. This is the answer. Now the question before us is, a heap of wheat is in the form of a cone whose diameter is 10.5 meter and height is 3 meter. We are to find the volume. The heap is to be covered by canvas to protect it from rain. Find the area of canvas. We have been given to assume pi is equal to 22 over 7. So this is the cone. Whose diameter from here to here it is 10.5 meter. This is the height which has been given as 3 meter. So here what is the radius? We have been given diameter. Diameter is equal to 10.5 meter. What is the value of radius? We know that the radius is half of diameter. Diameter divided by 2. 10.5 divided by 2, it comes as 5.25 meter. This is the value of radius. Now the height has been given as 3 meter. So what is the volume? We will calculate the volume of cone or heap. 1/3 pi r square h. We will fill in the values. What is the value of pi? It is 22/7. What is the value of r? It is 5.2.5. And what is the value of h? It is 3. 3 will be cut here, and we will arrive at the answer 86.625 cubic meter. So now we have been able to only find out only one portion, that is the volume of the heap, which has been come as 86.625 cubic meter. Now we are to find the area of the canvas which is to be used to protect the heap from rain. So what is the area of canvas? Area of canvas is equal to the curved surface area of the heap. Curved, it is curved surface area, CURVED, curved surface area of cone. Because the canvas is to be used to cover the wheat which is in the shape of cone. So what is the area of canvas which is required? It's equal to the curved surface area of the cone. Curved surface area of the cone is equal to pi r l. This is the formula to calculate the curved surface area of the cone, which will ultimately let us provide the result for the area of the canvas. Now we have the value of pi, we have the value of radius, but we don't have the value of slant height, that is L. We know that L square is equal to R square plus H square. Now we will here put the relevant values. L square is equal to R square means 5.2.5 square. What is the value of H? It is 3. What is the value of L alone? Now we will 5 to 5 square, it will come as 27.5625 and it will come as 9. Now it will come as 36.5625 and it will ultimately result into L will come as 6.046 meter. Now we have arrived at the value of L. We will fill in the values here to arrive at the area of the canvas which is required to cover the whole of wheat which is in the shape of cone. What is the value of pi? It is 22/7. What is the value of R? It is 5.25. What is the value of L? It is 6.046. When we solve it, the answer will come 99.66. So the area of canvas required is 99.66 cubic meter. Square meter, 99.66 square meter, because the curved surface area is in square meter. Now we will like to conclude this course that the cone is a three-dimensional geometric shape that consists of a circular base. The shape of the cone tapers smoothly from a circular base to a pointed top which resembles like an ice cream cone or a traffic cone. In a right circular cone, there is a relationship between slant height, height and radius, and it is denoted by L square is equal to R square plus height square. Volume of the cone is equal to 1/3 pi r square h, where pi is the mathematical constant which is approximately equal to 3.14159, and where r represents the radius of the base and h represents the height of the